Section 4.3 is about properties of logarithms. Okay, here are our objectives. We want to be able to use the product rule, the quotient rule, that's what that word is, quotient, sorry. We want to be able to use the power rule. We want to be able to expand logarithmic expressions and condense logarithmic expressions, and then use the change of base property, which anymore is totally useless. But we still need to know how to do it. Yes, we do. Yes, sir. Stanley? Are you serious? Stanley? Oh no. Oh, how sad. Ugh, Stan the man. Now we have to look and make sure that this is true and not just internet fake news. I know I'm recording. Yeah, it'll be for Jessica. You saw it? Oh no. So it is confirmed that Mr. Lee has passed away. Okay. That's really sad. No more cameos. I know. Okay, back to properties of logarithms. Properties of logarithms. All right, so let's talk first about the product rule. Okay, the product rule when we're talking about logarithms is something you already know. Okay, think about exponential rules. If I have b to the m times b to the n, what's the answer? If I'm multiplying like bases, what do I do with the exponents? Add, so b to the m plus n. That's a rule that you already know. Okay? Because you know how closely related logarithms and exponentials are, you know that there has to be a similar rule or law in logarithms. And in fact, there is. It's called the product rule. The product rule says if you have log base b of mn, that is the same as log base b of m plus log base b of n. Does that make sense? If I'm multiplying like bases, I add the exponents. If I'm multiplying terms inside the logarithms, it's the same as them being added. Got it? Guys, that's the product rule. I suppose I could give you a whole bunch more examples, but we're going to do examples in just a minute. I don't want to, stress you out by 15,000 examples. Okay? So, what about this one then? B to the m divided by b to the n. When you're dividing like bases, what do we do with the exponents? Subtract b to the m minus n. So on the logarithm side, that's the exponential side. On the logarithm side, we have the quotient rule. Which says log base b of m over n will equal log base b of m minus log base b of n. That's a weird n. I'm sorry about that. It's better. Now for all these rules, we need to make sure that we're realizing that m and n and b are all real numbers, all positive real numbers, and that b is not equal to 1. Because if b equals 1, 1 to any power is just 1. So none of these would really apply anymore. Okay? Everybody okay with that? Well, besides the product rule and the quotient rule, we have one more. Okay? Think of this rule on the exponential side. B to the m raised to the n. What happens here? B to the m times n. So that's the exponential side. Here's the logarithmic side. Log base b of m to the p power. That's going to equal p log base b of m. It's a multiplication thing. This exponent comes down in front as a multiplicator? A multiplier. I just made up a word apparently. Sorry. Okay. Oh, I forgot to write the name of the rule. That's the power rule. Okay? So the reason I didn't give you a whole bunch of examples of all these is because those were our first three objectives, the power rule, the quotient rule, and the product rule. Those are our first three objectives. But our next two objectives, expanding and condensing, we just have to have these rules so we can expand and condense. Okay? So, for example, expanding. Log base b of x squared times the square root of y. If I expand this, in the argument there can only be one variable. Okay, so I want to expand this so that each thing in the argument has its own log. Okay, so I could say log base b of x squared. What's going to happen between these two if these two are being multiplied? Add, plus log base b of the square root of y. Now, that's fine for now, but it's not the best we can do. Okay? Knowing the power rule, where if we have an exponent inside a logarithm, we need to bring that down in front as a multiplier, we would do that with this first one, right? This 2 up top, this 2 would come down front as a multiplier. 2 log base b of x. Okay? We also don't want to leave roots inside logarithms because we know that roots are really exponents, right? That's really y to the 1/2 power, isn't it? Well, if it's y to the 1/2 power, can't the 1/2 also come down in front as a multiplier? 1/2 log base b of y. So this sentence right here says the same as our original problem. This is just expanded. Okay? So what about this one? Log base 4 of the cube root of y over 36x to the 4th. So we want every part of this to have its own log. Okay? How many parts are there to this? Up here there were 2 parts, right? How many parts are there to this? 1, 2, 3. Yeah, don't count the 3 and the 6. That's really 36. Okay. So let's start with the log base 4. Now, what base is the log going to be for all of these? All of them? Yes, all of them, okay? So log base 4 of the cube root of y, and then what? Minus, because I'm dividing, log base 4 of 36. Ooh, now we have to figure out what to do. Because now I'm adding because it's multiplying right here, except both of those are in the denominator, so I really need to have a parentheses there if I'm going to put a plus right here. Log base 4 of x to the 4th. So that's just our first line, right? Where do you want to go to now? Well, what's this the same as? Y to the 1/3, right? So that can help me out because where is the 1/3 going to go? In the front is a multiplier. 1/3 log base 4 of y minus log base 4 of 36. But could I also put a minus right here? Isn't it like I'm distributing that negative sign to each one? So I could have done that from the beginning. Okay? What do I want to do here? Put the 4 in front. 4 log base 4 of x. So we're almost done. Because this is something we could figure out. 4 to what power equals 30? It would be something we could figure out if I would have written the problem correctly. Can I say that again? Because the original problem has a base of 6. Let's think about this real quick. Okay? 4 to what power equals 36? I don't know either. Okay, so we'd have to leave that alone. If I would have written the problem correctly from my notes right here, and that would have said log base 6 of 36, that equals 2, right? So I could erase this whole thing, even the log, I would erase this whole thing and just write 2. Okay? I know when you put these in the computer for your answers, it's going to want all the way simplified as possible. So if you left it like this and that was a 6, it's not going to want that. Okay? It's going to want you to put a 2 right here instead of a 6. Does that make sense? Okay. So any questions on expanding? We good? Okay, so condensing is just the other way. Condensing, we start with log base 4 of 2 plus log base 4 of 32. That's where we start. When we condense, we only write log one time. What are we going to do with these two numbers right here? Because they're being added, we multiply. So what is 2 times 32? 64. Do you happen to know off the top of your head what log base 4 of 64 is? It's 3, isn't it? Now, if somebody said to you, what's log base 4 of 64? I don't know. But you could really quickly convert it to exponential form. 4 to what power equals 64? Oh, well, that's 3, right? So I'd want a 3 as my answer. Okay? Log 4x minus 3 minus log of x. Oh, this one doesn't have a base. Oh, yes, it does. Okay, excellent. So I'd write log of what? I could write log base 10 if I want. Probably the computer won't like that. Okay, just if it says log, it just wants log. What am I doing here? Dividing. So 4x minus 3 over x. Is that something you can simplify? Yeah, you could expand it back, but you can't simplify it because x will go into 4x, but x won't go into 3, so you're done. That's it. One half log of x plus 4 log of x minus 1. Condense it. Where does that go? Because there's an exponent right there. Where does that go? Exponent right there, right? So I write log one time. Log x to the 1/2 times x minus 1 to the 4th. Done. God bless you. What if it didn't take this answer? What would you try instead? Would you remember that? I'm asking, would you please remember that? Okay. If you don't, I will help you. That's okay. 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. We want to condense this. How many times are we writing log? Once. Where's the 4 go? That's an exponent. Where's the 2 go? Exponent. Where's the 1/2 go? Okay so far? So I've got log x to the 4th. Minus means divide. So 6 squared, 36. Where's this one going to go? Is it going to go in the numerator or the denominator? Wait, am I going to divide it again? Yeah, but remember what we did up here when we subtracted? Don't they both go? That was all in the bottom, but they both were minus. So this just stays in the denominator, right? Y to the 1/2 power. No. If it was parentheses and then specifically, but that's dumb. so we probably won't do that. What did I write? Yes, thank you. Log base b. Good catch. If this didn't work, what would you try? Log base b of x to the fourth over 36 square root of y. Questions? Do you feel comfortable with product quotient and power rule? Can you expand and condense logarithms? Okay, all we have left is the change of base property. Why did I say that the change of base property is, I didn't even remember what I said. Silly? Unnecessary? Why? Our calculators do it for us now. Okay? Our calculators literally do it for us now. But I suppose there might be some situation where you would need to know this, so I'm going to teach it to you. Plus, they tell me I have to, so I say, okay. Log base b of m equals log of any base. We commonly use the common log because it's built into our calculator of m over log of b. Okay? Now, if you look in the book or in the textbook, they have an A here, a base A and a base A, except doing a change of base property to anything else besides a base of 10 is ridiculous, because then you'd have to do a change of base property on this one and on this one. So why don't you just put it in base 10? But that's just me. Okay? So if I say log base 4 of 7, what are you going to enter in the calculator to get an answer? Well, you guys are going to enter log base 4 of 7 and enter. But if you're doing change of base property, you're entering log of 7 over log of 4. Let me show you what I mean, just so you understand. Okay? In our calculators, zoom in. If I put in log, which is right here, okay, control log, I can put in log base 4 of 7 and it will do it for me. That is 1.40368. But what they're saying is that I need to know the change of base property, so that if I did log of 7 divided by log of 4, it would tell me the answer is 1.0368.